Then let me go over just a few things in the syllabus. I'm not going to read the whole thing to you, but I want to mention a few things, and then we'll look at my labs. I don't even know if I introduced myself. By the way, I'm Deborah Miles. I've been teaching at Rome State for 34 years. Yes, I started when I was 5. Um, I love it. That's why I keep coming back. I really, really enjoy helping students succeed. So I've got that, my office hours, my email, a bunch of stuff that you're going to know what all of that means by the end of the semester if you don't already know. Got a note about no textbook. Oh, a calculator. You can't use a graphing calculator in this class. You can only use a scientific calculator. You can get one with a fraction button is nice, but you can't have a graphing calculator because there are certain basic graphs that you need to know so well that you don't even need a calculator. You just know what absolute value of X looks like or cube root of X looks like. That's going to be important if you go on to calculus. You have to have good internet access. If you don't have it at home, then you need to work in the lab here at school. You've got to have internet access to do your homework. The main thing I wanted to show you in the syllabus was the grading procedure. We're going to have homework every day, and it will be assigned according to the calendar and done in my math lab. If you don't get a homework done, homework's set to always be due on the next class day at the beginning of the class at 11:30. So you can work on R.2 homework, which is tonight's homework, until 11:30 Monday, and then it's due. If you don't have a homework completed by the due date, you can continue to work on it up until the day of the test covering that section, but there's a 5% per day penalty for anything you turn in past the deadline. So really keep an eye on that. That 5% penalty is not going to hurt you if you just have a couple of them throughout the semester, but if you start putting off the homework until the night before the test and you have 5% penalty on all your homework, that's going to cause you a half a letter grade in your average. So watch out for that. I will drop your 2 lowest homework scores at the end of the semester. We have practice test in my lab that you have to do before you take the test, or it counts as a quiz grade. I also have an extra practice test you can print from Momentum just for extra practice. I recommend that you do both, not only because most folks need the practice, but if you only do the practice test in my labs, you don't have the feel of what it's going to feel like when I hand you a piece of paper. You need to do one practice test on paper just like it was the real thing, and that'll give you the same mindset that you're going to have when I lay a piece of paper in front of you on test day. We will have 5 tests, 4 chapter exams, and a mandatory comprehensive final. I don't give makeup tests at all ever, but I have lots of safety nets built in, and one safety net I have for you is a makeup day. If you look at the end of, or if you look at the calendar, there's one day at the end that says makeup day, and you can redo any one test that day. It can be a test you missed, you were sick, or whatever. You don't have to bring me excuses or funeral notices. If you miss a test, then you'll do it on makeup day. Or if you have one really low test grade, then you can do that test on makeup day. But I don't give any other makeups. All right, I think that's all that I wanted to show you in the syllabus. Oop, except for the bottom of the last page, I used to have that to-do list on the R.2 notes, but I spaced out the R.2 notes to give you more room to write and had to move my to-do list to here. So at the bottom of R.2.2 notes, you'll see See the to-do list on the last page of the syllabus. This is what you'll need to have done by Monday. Read the syllabus, do assignment 0, which is just the orientation assignment. It makes sure that you know how to type in certain expressions, fractions, radicals, and stuff in MyLab, and also ask you questions from the syllabus. So you'll have assignment 0, and then assignment 1 actually covers R.2, and you'll need to print the next set of notes and bring them to class with you. Suggested, make sure you're on Remind, you've registered for Radar Alert, you've organized your notebook, you've reviewed the course calendar, and then just play around with the websites that we're going to use this semester, Momentum and MyLabs. You can't break it by just punching links to see what they do. You might find some really cool, helpful things that way. All right, I'm going to pause one more time. Have you thought of anything you want to ask me yet? All right, let's go back to our home page and check out MyLab course home. This is your home page in MyLab. Now yours will look a little different than mine. Let me show you what yours looks like. Yours has a calendar and it shows you, oh dear, you're not supposed to have 26 assignments due tomorrow. I will see what that's about as soon as we finish. Somehow I didn't assign the right due date to 26 assignments. So I'll fix that. But the calendar will show you what's due. And let's see, what else do I want to show you there? That's everything that's due all semester. You may want to do that browser check where it says My Lab Math browser check. That's just to make sure that your device is compatible with MyLab. It's gotten much better at being friendly with Macs. It used to have a lot of glitches with Macs. But if you need any plugins or add-ins or anything like that, browser check will make you aware of what you need on your computer to make sure that MyLabs will run smoothly. And then I want to show you what one of your assignments will look like. And just any, mini, miny, mo, what about, let's say tonight's homework. You won't have to do this. This is just me accessing an assignment. All right. I may have changed something since last semester. I can't remember. I'll double check this too. But last semester, at the bottom of every problem, there were help tools such as View Example and Help Me Solve This. I believe I hit them this semester because what I found is folks were making hundreds on their homework and failing tests. One possible reason for that is using View Example on every problem. You're not really learning you're not learning the words and the process to go through in solving problems. You're just able to monkey see, monkey do if I give you an example just like it. So I will double check this after class, but I think I hid Help Me Solve This and View Example. The other thing that would be hidden as a result of that is the Ask Instructor button. But when you complete your homework and you submit it, let's go back to your home page a minute so I can show you this. Okay, go away. Oh, I keep clicking stuff on my laptop and I'm actually showing you my iPad. when you go to your grade book, any assignment that you've done, and right now there are no assignments done, but any assignment that you've done will, oh, some of you have done assignment 0, wonderful. In those assignments, that's where you will see the help me solve this and the view example and ask instructor. So what I want you to do when you do an assignment, if you don't make 100 on it, I want you to go to gradebook, click review, and see if you can figure out why you missed that problem. Either you can figure it out by view example or help me solve this. If neither one of those helps you figure out how to do the problem, then use ask instructor just to send me a link to it and say, here's my work. I've messed up. I can't figure out where I messed up. Please help. And I'll be happy to do that. So I think that's all I wanted to show you in my labs. Ashley, since you've done, Ashley Longnecker, since you've done that, let me show you what the grade book's going to look like.
Sure. No, I don't have hats. I have anuses.
Pardon?
Do the control players have anuses?
I didn't say anything. I was just listening to you say my name.
That's okay. Some guy's talking, but maybe wasn't talking to me. All right. So I'm just going to show you Ashley's 100 average right there. When you click on grade book, that's what you will see, your name and your current average, and any assignment that you've done has that review beside it. And that's where you can click it. You can see what you missed. You can click on any problems that you missed, and then you can send me a link to the problem if you need help with it. All right. That's a lot of stuff, but that's all I can think to tell you. Unless you have another question you'd like to ask. All right, y'all aren't going to be shy in class, right? It's okay to be shy via Zoom, but in class you're going to talk to me so I can figure out what you need help with. Let's go ahead. I'd rather talk to you than just have you watch a video. So let's go ahead and see how far we get in the R.2 notes, and then just remember whatever we don't cover. If you're totally okay with exponents, you don't need to watch any more video. But if you look at the examples and the rest of your notes and you say, man, I'm going to struggle with this, then you need to go watch the rest of that video before you start the homework. All right. Now we're going to start out with something that sounds elementary and boring, but I want to make sure that you understand why everything is what it is in math. Nothing in math was invented with the express purpose of driving you crazy or seeing how many folks we could keep from graduating college. Everything in math is what it is because somebody noticed a pattern or somebody knew a way to check an answer. And I want to make sure that you understand, especially these this part B, oops, this part B and that part C. You're going to see expressions like that when we get to linear equations, the slope formula. And I never want you to leave 0 over 4 or 4 over 0 as an answer. If you leave that as an answer, I know that you don't really know what it is. So let's talk about the domain of an expression and how you check answers when you divide. Anytime I use the word domain, I'm referring to the values of the variable for which the function is defined. Now, when I say for which the function is defined, well, what's undefined? Let's go ahead and look at these first 3 examples, and then you can answer that for me. Just to show you the checkability of division. You know that 8 divided by 4 is 2. You've known it for a long, long time. Sorry. But you can check it just by multiplying your answer times the denominator. Better give you your numerator. And certainly it does. And if you can check 8 divided by 4 in that way, you can check the other two in that way. 0 divided by 4. If you have no cookies to divide among your 4 children, how many cookies does each child get? No cookies. And that's the right answer. I know it's the right answer. It checks just like I checked this first example. I multiply the answer times the denominator. It does give me the numerator, so I know it's the right answer. Now, that's not the one 9 out of 10 dentists surveyed miss. 9 out of 10 dentists surveyed miss that part C, 4 divided by 0. Imagine 4 cookies divided by 0 children. That doesn't even make sense. I have folks who maybe think it's 0 also, but if you're taking notes on this handout, make sure you put not equals there. Because it doesn't check. 0 times the denominator does not give you the numerator. So that answer can't be 0. And if we sat here a while and tried to think of a number that you multiply times 0 and get 4, what would we come up with? What can you multiply by 0 and get 4? Somebody talk to me, please.
Nothing.
And by nothing, do you mean 0? Is that what you mean when you say nothing?
No, anything times 0 is 0.
Oh, you mean there is nothing you can multiply by 0 to get 4. And you're absolutely right. So there's a special word we use for that expression, 4 divided by 0. We could write no such thing. We could write nothing, but there's another word we use in math. What's that word? 4 divided by 0 is?
Undefined.
Yes, that's it. It's undefined because you can't divide by 0. You can't find a number you multiply by 0 to get any other number. So in this definition at the top of the page where I said the domain is an algebraic expression, the variable cannot be any number that would make the expression undefined. One of the things that makes the expression undefined is 0 in the denominator. And another thing that makes an expression not undefined, but not a real number is the square root of a negative. Now, we can do something with square root of a negative, and we'll talk about it later. But right now, we're just going to say square root of negative is not a real number, so it's not in the domain of the expression. These next 3 examples just ask you for the domain. And to find the domain, first you have to think, well, what can x not be? So this first one, 5 over x minus 2, what could x not be? The only thing that would blow up that expression.
2.
Yeah, x can't be 2. 2 is what must be excluded from the domain. If I just ask you for the domain, you can say, oh, shoot. No, don't say, oh, shoot. You can say x cannot be equal to 2. And I'm not sure which way my lab will ask you in the homework. If it says find the domain, you'll say x can be anything but 2, or x is not equal to 2. But if it said give the values that must be excluded or left out of the domain, then you'll just answer 2. 2 is what has to be left out. You see the difference between those two things? Find the domain or find what is excluded from the domain. Now, these last 2 expressions involve radicals, and Again, you're just asking yourself, what can I let X be? That would give me a real number. Or first you might need to think, what can I not let X be? Can anybody give me an example in that B part of a number that you could not let X be?
-2.
-2, because that would give you square root of -4, and that's not a real number. Perfect. Somebody give me a value you could let X be. Infinitely many right answers here. I
Two.
just want, what's that?
2.
Yeah, you could let X be 2 because then you'd have square root of 0, and square root of 0 is a real number. It's just 0. So you've given me one example of something X can be, and you've given me one example of what X cannot be. Can you explain to me in words what kind of numbers you could let X be? Instead of just giving me one example, tell me in words all the numbers I could let X be.
Any number greater than 0?
What about 1? You said any number greater than 0. Could I let X be 1 there? What would happen if I let X be 1? Would that be a real number?
It'll give you -1.
Oh, it'd give you square root of -1, and that's not a real number. So it's got to be something else. It's not just anything bigger than 1. Somebody else want to take a stab at that?
It's anything above 3.
All right, anything above 3 would certainly work. For example, I could use 4. I could say square root of 4 minus 2. Yes, that would definitely be a real number. But what about 2.5? Could I let X be 2.5?
Yes.
Oh, because square root of 1/2 is a real number. So you haven't quite nailed it yet. It's not any number greater than 0. It's not any number greater than 3.
Greater than or equal to 2?
Oh, anything. Let me just start with part of that to begin with. You said anything greater than 2? Yeah, I can use anything greater than 2. I can use 2.1 or 2.001. And then the other part of what you said was anything greater than or equal to 2. Can I let X be 2?
Yeah.
Yeah, I can. So the domain is exactly what you said in words, anything greater than or equal to 2, or using math symbols, we would write that X is greater than or equal to 2. Now that one's pretty easy to figure out in your head. You can just think, what kind of numbers can you subtract 2 from and still get a 0 and still get a real number? Well, anything bigger than 2. But if you have a problem that is a little more complex than that, and you need to find out the domain, you can just always say the radicand. I'm using a new word here. The radicand is the expression under the radical. That has to be greater than or equal to 0. And then when you add 2 to both sides, that gives you the domain that we wrote. All right, last one of these. Square root of 2 minus x. What kind of numbers can I subtract from 2 and take the square root and still get a real number?
Anything less than or equal to -1?
All right, let's see. See if I can use -1. Square root of 2 minus -1. Yep, that's square root of 3. -1 would be in the domain. And you said anything, did you say less than or greater than -1?
Less than.
Less than. So -2, could I let x be -2? Yep, I could. Or -3. Yeah, I could let x be anything less than 2. But what about, or excuse me, less than -2? But what about something bigger than -2? Could I let x be 0?
The x is anything less than or equal to 2.
Yes, that's it. I can let x be 0, and I can let x be 1, and I can let x be 1.99999, but I can't let x be anything bigger than 2. I can only let x be numbers that are less than or equal to 2. I can let x be 2 because then I'd have square root of 0, and that's fine. I just can't let x be anything bigger than 2. All right, let's go on to exponents, the main thing in R.2. It is my hope that I can make all the rules of math that we're going to encounter make sense to you. Because if you're just memorizing crap that doesn't make sense, your brain's going to get full of crap. And you're going to be just sitting there on tests not knowing what to do because you memorized a lot of rules that don't make sense. And I would be remiss in my duties as a teacher if I didn't try to explain why things are like they are. That's always going to be my goal. So let's start with some terminology. I know what exponents look like, little numbers up in the air, and the definition of an exponential expression, a to the m, is just repeated multiplications. A is called the base, m is called the exponent, and the exponent tells you how many times you multiply the base by itself. A to the third would be multiply a by itself 3 times. You already know that. What you may not be paying close attention to, though, is this caution that I have out to the side. You always have to pay attention to the base. Without parentheses, the base is only what's immediately below the exponent and doesn't include the sign before the number or variable. If it's not in parentheses, it's not part of the base. Now, I can make that clear with these next 2 examples. 9 out of 10 dentists surveyed will get that first example right. The -5 is in parentheses, so the base is -5. And anything squared means multiply by itself. So I'm going to multiply -5 by itself, and I get +25. No big deal, piece of cake. But 9 out of 10 dentists surveyed will miss number 2 because of not paying attention to the base. They think it's just like number 1. Well, it's not. The negative's not in parentheses, so the base doesn't include the negative. The base is just +5. Now let me compare this to something else for a second. If I just write the expression -x, what is its coefficient understood to be? What's the number?
Can you say that again? I'm sorry.
Jet. Jet.
What is the coefficient of that -x that I just wrote up in the corner? Coefficient is number in front of the variable.
1.
Actually, because of the negative, it's -1. We don't write that 1, but we know it's there because that's the coefficient that's understood to be the coefficient of any variable without a number written in front of it. So the coefficient's -1. If I wanted to write -x², then the coefficient is still -1. So going back to what we were looking at, it may help my eyeballs if I can write this -5² the same way I wrote that -x². I'm going to write it as -1 times 5 squared. And that will really help my eyeballs understand that that negative's not part of the base. It will help you understand why the answer here is -25 when the other answer was +25. It all comes down to the negative's not part of the base.
So would the negative only be included if it was in parentheses?
That's exactly right. That's exactly right. And that's what I meant with this highlighting right here. I just erased it, but that's exactly what it says. Without parentheses, the negative's not part of the base. All right. Now, if you'd never had a math class and I just ask you, hey, what do you think anything to the 0 is? What would be the most reasonable guess? Do you think anything to the 0 sounds like it should be?
0.
That would be my first guess. Anything to the 0 seems like it ought to be 0. And so I've written this definition for you. Actually, anything to the 0 is 1. And that sounds like a prime example of crap that's made up by somebody who hated me a million years ago. Nothing in math was developed that way. Everything in math is what it is because somebody noticed a pattern and then proved that that pattern always held, except for every once in a while there's an exception. If there is a exception, it has to be included as part of the definition. That's what that A is not equal to 0 is there for, and we'll come back to that in just a minute. But I want to show you the pattern that gave us that definition. We could start with any exponential expression or equation that was true. 3 to the 4th equals 81 is definitely a true statement. It's an equation. It states that two things are equal. And I know that one thing that I can do with an equation and still have an equation that's true is I can divide both sides of the equation by the same number. So I decided to divide both sides by 3. And on the left-hand side, 3 to the 4th divided by 3 would be down to 3 cubed. And on the right, 81 divided by 3 is 27. Still a true statement. Let's do that again. The left-hand side would be down to 3 squared. And the right-hand side would be down to 9. Still a true statement. Let's do it again. 3 squared divided by 3 would get us down to 3 to the 1st. 9 divided by 3 would get us down to 3. Actually, I could have written out to the side, that's the definition of the exponent 1. Anything to the 1st is itself. What's happening to the exponent on the left-hand side every time I divide by 3?
I was about to ask, you're just subtracting, aren't you?
Yeah, it's going down 1. I started with 3 to the 4th, divided by 3 was 3 cubed, divided by 3 is 3 squared. Every time I divide by 3, that exponent goes down 1. So the next time I divide by 3, that exponent's going to be what?
0.
0. And on the right-hand side, if I divide by 3, what's 3 divided by 3?
1.
And that's why anything to the 0 is 1,
So,
rather than anything to the 0 is 0. Yes.
so does that only work if the numbers are divisible by each other? Like if you had 4 instead of 3?
Okay, let me show you. If I had started out with 4 cubed equals 64, and I kept dividing both sides by 4, I would have come up with the same thing. Something to the 0 is always, always, always 1.
Okay.
All right. So that's why the definition is what it is. Anything to the 0 is 1. And the exception, A cannot be 0 or the base cannot be 0. We're not really going to talk about that until Calculus 2, if you want to join me there someday. In Calculus 2, we'll learn that 0 to the 0 is an entirely different something. It's something called indeterminate form. Not going to worry about it now. But anything other than 0 raised to the 0 power gives you 1. If we follow that pattern another step, then we'll learn another important property of exponents. If we divide by both sides by 3 again, starting right here, then the next exponent is going to be -1. 1 below 0 is -1. What about the right-hand side? If I divide by 1 by 3 and just leave it a fraction, what would that be?
1/3.
Yeah, it'd be 1/3. So this is the first time I've encountered a negative exponent, and I'm trying to figure out what that means. Maybe I need to do this one more time. If I divided both sides by 3 again, on the left-hand side, I'd subtract 1. The exponent is now -2. 3 to the -2 is the left-hand side. On the right-hand side, what is 1 divided by 3? I'm sorry, 1/3 divided by 3 if I just leave it a fraction. One-third of something chopped into 3 pieces. Somebody tell me what 1/3 divided by 3 is, or I'm going to cry.
1/9.
Yes, thank you. It's 1/9. Take a third of something, a third of a pizza, and you cut each of those thirds into thirds, and the size of each slice is 1/9 of what it started with. Now, I think I've noticed a pattern here. That 3 to the -1 is 1/3. I could write it as 1/3 to the first. It's still just 1/3, but there's something I want to show you by writing it that way. That 1/9, I could write it as 1/3 squared. Is that the same thing as 1/9? Yeah, it is.
So, do they have to have the parentheses, or can you write them without the parentheses with the exponents?
That's an excellent question, and actually just about the next thing I was fixing to say. So hang on to that idea 1 minute. I'm glad you asked. What I have just discovered, like I invented it, is that when I take the reciprocal of the base, now think about those words, this 3 to the -1. What do I mean when I say reciprocal of 3? What is the reciprocal of 3?
1/3.
1/3. Taking the reciprocal of the base makes the exponent positive. When I flipped that 3 and got 1/3, now it's to the +1. When I flipped that 3 and got 1/3 on the last line, now my exponent is positive. So taking the reciprocal of the base makes the exponent positive. And then somebody said, could I write that without parentheses? The answer is absolutely yes, because when you take the reciprocal of a whole number, you're going to have 1 in the numerator. 1 to any power is still 1. So I usually just write that as 1/3 squared instead of 1/3 squared, but they're both 1/9. And that has led us to the definition of a negative exponent. Anytime I see a negative exponent, that word reciprocal is going to pop in my head. If we were live in person, I could hypnotize you so you never forget that.
I'm so
But
sorry to interrupt you, but
oh, you're fine.
On the last question, is that how you want us to put our answer in the homework, is the 1/3 squared?
Well, the most simplified answer is the answer that I would want in the homework. So it's actually what I would want you to give me as the answer is 1/9.
Okay,
Just wrote it the other way to help you see what a negative exponent means.
okay, that's all, sorry.
Yeah, no problem. Yeah, good question. Whenever I see a negative exponent, like a to the negative n, I'm going to take the reciprocal of a, that's 1/a, and then it's to the positive n. And that rule has the same exception as the definition of the zero exponent. You can't let the base be zero. All right. Let's see these next 10 examples. If we had lots and lots of time, I like to stop and ask you to help me with the answer. Because we don't have lots and lots of time, I'm just going to give you the answer to these. I'm going to show the middle steps and give you the answer. But in class, I like for folks to give me the answer. I think that saying things out loud make them stick in your head better and really show an understanding. So these 10 examples are really getting at, do you understand the zero exponent? Do you understand the negative exponent? And are you paying attention to the base? You can see if you've mastered those three things by doing these 10 examples. Number one, anything to the zero. That's just the definition of the zero exponent. Anything to the zero is 1. Number two, oh, let me write out beside that. The base there is 5. Number two, because of the parentheses, the base is the whole thing in parentheses, the 5x. It's still just something to the zero, and something to the zero is always 1. But number 3 is not the same thing. Number 3 doesn't have the parentheses, and without the parentheses, the base is just the x. And if you're having any trouble at all making your eyes see that that 5 is not part of the base, you could use our good friend, the multiplication dot. Putting a dot between that 5 and x to the 0 makes it very clear to my eyeballs that the 5's not part of the base. That's just 5 times 1, and 5 times 1 is just 5. So those parentheses made a big difference. In example 2, that was 1, but example 3, without the parentheses, that's 5. All right, number 4, the base of that -2 is 5. And when I see a negative exponent, y'all tell me what R word pops in my head?
Reciprocal.
Reciprocal. Taking the reciprocal of the base, the reciprocal of 5 is 1/5, makes the exponent positive. I can either put it in parentheses, and I usually don't write it that way. I usually just write it 1/5 squared. But then you want to give as your answer, the most simplified form of that is 1/25. All right, 5 and 6 look very similar, except for one parenthesis has parentheses and one doesn't. The one without parentheses, maybe the dot will help your eyeballs again. The base of the -2 is just the x. And so the only thing you're going to take the reciprocal of is just the x. That's 5 times the reciprocal of x to the +2. And if you put that 5 over 1, you can express that answer as a single fraction, 5 over x squared. Now, if anybody has a question, you can interrupt me and it's fine. I want this to make sense to you. Number 6 looked a lot like number 5, except for the parentheses. The base of that expression is 5x. And it's to a negative exponent. When I see that negative exponent, the word reciprocal pops in my head. Take the reciprocal of 5x, and then it's to the positive 2. But I've made a very common mistake here, and I actually made it on purpose, so that you could watch out for this. Why is the expression I just wrote in blue not equivalent to the original expression?
Don't you still have to keep the parentheses?
Yes, because right here, the 5 is part of the base. Here, what I wrote in blue, the 5 is not part of the base. The only way to keep that 5 as part of the base is to have it in parentheses. If I were in class with you, we'd high five. Good job. If you need the 5 to stay part of the base, you need to keep the parentheses, but then you want to write your answer the simplest way possible. So say 5x times 5x is 25x squared, and then you don't need the parentheses. All right, number 7, the base is -5 because the base is in parentheses. And so I'm going to take the reciprocal of -5. What's the reciprocal of -5?
One-fifth.
Is it positive 1/5?
It's negative, but I was gonna ask you.
Yes. Yes, I know.
So if you take the when you take the reciprocal of a coefficient, it'll make it positive. But if you take the reciprocal of the
Nope.
base,
That's not right. Let me get you the right words here. Taking the reciprocal of the base makes what positive?
the exponent.
Makes the exponent positive. When you take the reciprocal of -5, it's still negative. It's -1/5.
Yeah, I was just
But
gonna ask.
Yeah, but it makes the exponent positive.
Okay.
You know what? You really can't use pronouns in a math class. If you say it makes it positive, I don't know what it refers to. So you have to say it makes the exponent positive, and that makes sense. Ashley, is that okay now?
Yeah, I was just confused about the basis and exponents. That's good.
And I knew that several folks would be, and that's why I wanted to refer you back up here to what that note says. Take the reciprocal of the base makes the exponent positive. All right. So as simply as possible, -1/5 times -1/5 is positive 1/25. Not because you flipped the 5, but because a negative times a negative is a positive. Number 8 is not the same thing. Without parentheses, that negative is not part of the base. And what may help your eyeballs see that is if you write it -1 times 5 to the -2. You don't have to write that if you don't need it, but if you're getting the sign of your answer wrong, then maybe writing that dot to separate the -1 from the 5 to the -2, maybe that'll help. So the only thing you take the reciprocal of is the 5, and that makes the exponent positive. So your answer is actually negative 1/25. All right, last two. Number 9. No parentheses. So the base of that -2 is just x. Maybe a dot would help me. -5 times x to the -2. And that negative exponent makes me write that as -5 times 1 over x to the +2. And when I put that -5 over 1 so that I can write my answer as a single fraction, -5 over x squared. Now, I am training all of you to be tutors because you know math well when you can explain it to somebody else, when you have the right words to explain it to somebody else. So let me tell you what a very frustrated student is going to come into the tutor center and say, and somebody help me explain, talk that student down off the ledge. What would you say to a student who said this? On number 9, I'm really angry because you said put x in the denominator because it was negative. Why isn't the 5 in the denominator? It's negative also. What would you say to that person?
The 5 has no affiliation with the exponent. It doesn't have a reason to be in the denominator.
Okay, I'm playing angry student again, but it's negative. It's negative. Why doesn't it go in the denominator? Because it's negative.
It's not negative because it's not in parentheses.
The 5 is negative.
Is that you
That's-
said?
Because the exponent doesn't change what base isn't attached to it. It doesn't mess with the 5. The negative only the -2 only affiliates with the x. That's why it's in the denominator to turn positive. The -5 isn't going to change.
Okay. I can't think of a different way to state what I'm angry about. And you're hitting all around it. You're close. But let me say what I'm angry about one more time. The 5 is negative. Why doesn't it go in the denominator? Here's the answer. Yes, the 5 is negative. Hold on. But its exponent is not negative. The exponent of that 5 is 1. And so that's why it doesn't go in the denominator. It has a positive exponent. A negative number, a negative coefficient's not the same thing as a negative exponent. And we're only saying factors with negative exponents go in the denominator. All right. Now I think I realized a pattern here, and I actually just said it. I think, and if this is true, I'm going to call it the Miles law of exponents. I think any factor like the x that has a negative exponent is going to end up in the denominator. I think that's true. The x had a negative exponent, the x ended up in the denominator. The -5 had a positive exponent, it ended up in the numerator. So I'm wondering if I can say that's always true. Anything with a negative exponent is going to be in the denominator. Anything with a positive exponent is going to be in the numerator. Hang on to that while we do number 10, and then we'll see if that's a rule that I can name after myself. Number 10, that's all, those are all factors. They're things multiplied together. So I can separate them with dots if I want to. That -12 can be separated by multiplication from that x to the -3. And since that x has a negative exponent, I'm going to write it as 1 over x cubed. Since the y has a positive exponent, I'm just going to write it y to the 5th. Or if I want it as a fraction, I could put it y to the 5th over 1. That's the same thing. And then the z has a negative exponent, so I'll take the reciprocal, and that makes its exponent positive. I can also put that negative 12 over 1, so that when I multiply straight across to get a single fraction, my answer is going to be negative 12y to the 5th divided by x cubed z. And I could write z to the 1st, but I don't have to. So let's go back to the Miles rule for exponents. Is it always true that anything with a positive, or any factor, let me say any factor, with a positive exponent ends up in the numerator? Did that happen to be true in this problem? The negative 12 and the y ended up in the numerator, and anything with a negative exponent ends up in the denominator? It did. But let me tell you why I can't put that rule in a math book and name it after myself. What I've been saying is any factor with a negative exponent ends up in the denominator. That's not true, because something could start out in the denominator with a negative exponent. If it starts out in the denominator and has a negative exponent, where will it be when you write it with a positive exponent?
In the numerator.
Yeah, so the good old Miles law of exponents. That's why you've never read it in a book. It's not correct. All right. And the angry student scenario, actually, I wrote this caution just for them. On number 9, the person who kept thinking the 5 is negative. Why don't I put it in the denominator? It's negative. Here's what you can say to that person. The sign of a number has nothing to do with the sign of its exponent. Yes, the 5 was negative, but it had a positive exponent. You never take the reciprocal of a number just because it's negative, like the negative 5. You only take the reciprocal of the factors that have negative exponents. And that's why we can't say it's negative. We have to say the exponent is negative or the coefficient is negative.
Okay, so if it was just -5 to the -2nd without the x,
Oh, actually, that may be.
it's
Look at number 7 and number 8.
yeah. So without the parentheses,
But we're on the
it would
top.
still be negative, correct?
Well,
Would-
you're still using the word it, and I
Sorry, the 5 would still be negative.
What's your name?
don't. In your mind, is that looking like number 7 or number 8? Number 8's what you're imagining.
Yeah, I
Number,
was thinking of like reciprocals too. I was just confusing it.
are you okay now?
Yeah, I think I'll be okay.
Okay, all right. We are never gonna get everything I want to do. I mean, I love math so much, we could just hang out the rest of the day and I would explain all of math to you. Actually, that would take more than a day. We are never gonna have time for that. So when we run out of time, we have to stay on schedule. If we get behind, it's just like in your homework. If you get behind, you never catch up. So when we run out of time, you can go to the video on YouTube and make sure you're not just searching for a video in YouTube. Make sure you're clicking the YouTube link on our momentum page. Why is my pen not writing? I have the part 2 video has that last 13 minutes. The part 1 video would cover the product rule and the quotient rule at the very, very end, maybe the last 2 minutes of part 1, and then part 2, and you can finish those notes. Now, because it's so important to me that you understand the product rule and the quotient rule, here's what I'm going to do. It's 12:50, class is over. You are absolutely welcome to go wherever you have to go, whatever you have to do, that's fine. But it's so important to me that you understand the product rule, the quotient rule, and the very first power rule, that if you hang around 5 more minutes, I will explain those 3 and you won't have to watch them on video. All right. Anybody that wants to go, see ya. I hope we are in class on Monday. I think we will be. And I don't know how many folks are still with me. Looks like several. Oh, 14 of you are still with me. Yay. Somebody just stuck something. Joseph, go get your oil change. That's absolutely fine. Don't worry. You can watch the video if you need to. But the 13 or so that are left, I'm going to zip through this product rule, quotient rule, first power rule super fast, because I know a lot of people just memorize these without understanding them. And if you memorize it, this first example, 7 cubed times 7 squared, if you just memorize something, you're going to be sitting there on the test. Let's say I make this problem multiple choice. Here's the 4 choices I would give you. And if you don't think about what 7 cubed times 7 squared means, that B is 7 to the 5th. It looks like 75. If you don't think about what that means, then you're just going to take your chances guessing, and you got a 25% chance of getting it right by guessing. If you think about what that means, it's perfectly clear which one of those 4 answers it is. 7 cubed means 7 times 7 times 7. And 7 squared means 7 times 7. If you write out what each of those expressions means, then it's obvious that the answer is, which one? Is it A, B, C, or D? We have,
D.
we have 5 7s multiplied together, and that's what 7 to the 5th means. So it's B. But folks who don't understand that that's what it means are sitting there on the test going, is that where you add the exponents, or is that where you multiply the exponents? Well, if you understood, you wouldn't be having to memorize crap. A to the m times a to the n, you just add the exponents. Because if you're multiplying 3 7s and then 2 7s, you're multiplying 5 7s.
You only add if the bases are the same, or is that wrong?
When the bases are the same. If that were 7, I think my pen's about to die on me. If that were 7 cubed times 4 squared, you couldn't use the quotient rule or the power rule, excuse me, the product rule. You'd have to multiply out 7 cubed times 16, whatever that is.
Okay.
There's a caution. There's a reason people choose answer D, 49 to the 5th. If you choose 49 to the 5th, you're right, you have 5 somethings, but you don't have 5 49s, you have 5 7s. So don't multiply the bases. You have 3 7s and 2 7s is 5 7s, not 5 49s. You can figure out the quotient rule by writing what it means. You can say 3 to the 6 divided by 3 squared. That means 6 3s. The product of 6 3s divided by the product of 2 3s. And I know that one way to simplify fractions is to divide out common factors. You can say this 3 divided by 3 is 1. This 3 divided by 3 is 1. So what do I have left? Well, I have 4 3s left. And I would have gotten that 4 if I had done what to the original exponents? The 6 and the 2?
Subtracted.
Yeah, if I just subtracted the bottom exponent from the top exponent, I would have gotten that 4. So that's why the quotient rule says a to the m divided by a to the n is a to the m minus n. Subtract the bottom exponent from the top exponent. The same caution applies. Some folks expect that answer to be 1 to the 4th, because 3 divided by 3 is 1. But we weren't left with 4 1s, we were left with 4 3s. So don't divide the bases, just subtract the bottom exponent from the top exponent. And the last one that I want to take time to explain, because this is the one most often confused with the product rule. Folks who are going, I don't know when to multiply and I don't know when to add. They're confusing the product rule and this first power rule. The first power rule says, we'll figure it out from the example. If we have x squared cubed, I know what cubing means. Cubing means multiplying something by itself 3 times. So that's what x squared cubed means. And actually, breaking it down further, that means x times x times x times x times x times x. So how many x's do we have?
6.
And so that's x to the 6th. The most common wrong answer is x to the 5th. I don't have 5 x's, I have 6 x's, which is what I would have gotten if I had done what to these original exponents? What can I do with a 2 and a 3 that'll give me a 6?
Multiply.
And that's why the first power rule says a to the m raised to the nth power. You just multiply the exponents. All right. Thank you for joining me on Zoom. Thank you for giving me an extra 6 minutes to explain something that I really wanted to make sure you understood. There's a little bit left. I would say that last 10 minutes of the part 2 video, and you can finish those up. And your to-do list is on the last page of the syllabus. We've already talked about it. Please make sure you've signed up for Remind so you don't miss any important announcements. And I'm going to end this session before I think of something else to say. Y'all have a good day.
Miss Miles, can you hold up a sec?
Yes, I can. Yes, absolutely. What can I do for you, Shelby?
Can you go back up to the power rules?
Power rules. Yes, ma'am.
Okay, I understand the first one.
Okay.
How would you hear the second one?
Well, the same way that we've developed all the others, we can look at an example. That 5x cubed in parentheses squared, that means 5x cubed times itself, right? Is that what that means? Yes, that's what that means. And looking at that, I notice I have 2 5s multiplied together. And I have 2 x cubes multiplied together.
That's what I thought, but the caution underneath it says never multiply a coefficient by an exponent.
Yep. Hang on to that 1 minute. We're going to take this one step further and say that's just 25x to the 6. 25x to the 6 is my answer. All of that other stuff just helped me understand why that's the answer. So far, so good, Shelby? I'm not finished, but so far, so good?
Yeah.
Okay. Now, the caution, or let me write the second power rule. The second power rule says a product to a power, you just raise each factor to the power. And that's what we did in that example. We just squared the 5 and squared the x cubed. But if I'm playing angry, frustrated math student again, here's what I'm going to come into the tutor center and say. I hate math because the rules change in every problem. I hear that sometimes. And what that person is referring to is you multiplied the 2 times the 3. Why didn't you multiply the 2 times the 5? What would you say to that person? Can you think of any way to explain why you multiplied the 2 times the 3, but you don't multiply the 2 times the 5?
Would it be because the 5 has an exponent of 1?
Yes, it's you only multiply exponents. Good job. You only multiply exponents by other exponents. That 5's not an exponent. It has an exponent. Its exponent's 1. And you multiply the 2 times the 1, just like you multiply the 2 times the 3. And that is the first part of that caution. You never multiply a coefficient by an exponent. You only multiply exponents by exponents. Shelby, did that make that more clear for you?
Yeah, I kind of forgot that there was a 1 with a 5, and I think that's where I got
Yes,
confused.
yes. And that's why you don't have to write that 1, but if it helps your eyeballs, you write it, sister. You got it?
I got it.
You need to ask anything else?
Just one more question. I'm sorry.
Hey, you're helping me do the job I love the most. What can I do for you?
So on number 3, I'm just gonna take a stab at guessing.
Okay. I
So
like
you would distribute the M to the A and the B.
Distribute's
then-
not actually the right word for it. I know why you're using it, but the distributive property means something else in math.
Like you would multiply the exponent, like
Yes,
the exponent
yes.
with it with the one outside.
That's a good thing to say. You can say, wake up my pen here. You can say the 2 has an exponent of 1 and the 3 has an exponent of 1. You multiply the 4 times the 1 in the numerator, and you multiply the 4 times the 1 in the denominator.
So then does it become the quotient rule, or do you just solve it out?
The quotient rule only applies when you have the same base, and I don't have the same base on those 2 expressions. Oh, my pen is dying.
You would just solve it out like you would any other.
You would evaluate that expression. 2 to the 4th is 16, 3 to the 4th is 81.
And then simplify it if you can.
Correct. And that
Okay.
happens not to simplify, so just leave it 16 over 81. But if it would simplify, then you should. And the reason that I really like to put that one on here, Shelby, a lot of folks just grab their calculator when they see 2/3 to the 4th. They just grab their calculator. And if you punch on the calculator 2/3 to the 4th, then your calculator gives you 0.19 something, 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 and it goes on and on and on. That's not the answer I want, because that's not the exact answer. The exact answer is 16 over 81. This is just a decimal approximation. So to get the exact answer, you need to raise 2 to the 4th and 3 to the 4th. It's not hard to do, but folks are just so used to reaching for their calculator that they don't stop and think, well, what does that mean? Anything else you want to talk about, Miss Shelby?
No, that was good. Just watching a video doesn't always make sense to me, so.
Yeah, I know. That's why I could have, right after we talked about the syllabus, I could have said, now go watch the video, but I'd rather talk to you. And then when we absolutely run out of time, then you can finish up those last few examples with the video. I'd say you probably have, yeah, about 10 minutes of video will get you through those last four. And it would be helpful to see those because the ones on the homework are a little bit more difficult than what we got to in class. They're more like 88 to 96. So watch that video.